Hello, everyone. Let's go over exam 3 notes. Exam 3 will have about 29 questions, and you have roughly an hour to get all those done. So it's quite a bit shorter than the other two exams, and so this notes review will be pretty quick as well. Let's start with databases. A database is just a collection of tables and the relationships between those tables, and tables will also refer to as entities. Um, and then within tables, you have rows and columns. A row is also called a record. And so inside a table, say called cars, you would have, you could have a manufacturer, a model, a color, a license. So these are all considered attributes for that table, the columns, and then each row is a record. So this is one row. So you have manufacturer number 2, you have a Civic in the model, color is black, and the license number. So all these together form a record for a car, defined by different attributes, which are in the columns. So between multiple tables, you would have relationships that kind of explain how the two tables are related to each other. So there are various forms of relationships. Two specific ones that we want to focus on are one-to-many or one-to-one. So in the example of a manufacturer and a car, say you have a manufacturer table and a car table. So the manufacturer table looks something like this, where you have different manufacturers like Mercedes, Honda, and then you have a car table where you have different models of individual cars. You would have, you could have many manufacturers with different models in the cars table. So you could have Honda showing up twice or 3 times, depending on, whether you have a Civic, or I'm blanking on another Honda right now, but you could have multiple models. You could even have multiple Civics. So in the end, they're all going to refer back to key number 2, which is Honda in the manufacturer table. So for each manufacturer in the manufacturer table, there can be 0 or more related cars. For each car in the cars table, there can be only one manufacturer in the manufacturer's table, because a Civic won't have, usually, or at least in the way this database was designed, they can't have more than one manufacturer. So this is a one-to-many relationship. So one manufacturer, many cars. In contrast, say there's another table called license, and that holds all the license plate numbers. Each license plate can only refer to one car, and each car can only have one license plate. So in that case, that's a one-to-one relationship between a car and a license. Moving forward from that, we kind of already went over this, but keys are what enforce the integrity of a database, meaning that you can't have multiple records that share the same key. And so primary keys are unique. They identify a row in the table. Each one will have their own primary key. We don't always show the primary key when we create these quick diagrams. So sometimes you'll see them, sometimes you won't. So like over here, you see that I have a primary key identified in this picture. So manufacturer, each manufacturer has their own primary key, but then over here in the cars table, I didn't show it. But I'm showing you the relationship here. So you have the primary key for this table, and to relate the manufacturer table to the car table, we would just place the primary key in here as a foreign key, and that's the relationship right there. So to relate the car manufacturer, we'll add the primary key of the manufacturer and place it in the manufacturer column of the car table. In the car table, this will be referred to as a foreign key. Moving forward, an entity relationship diagram is a diagram that shows tables or entities in a database with their attributes and fields associated with the tables and how the tables relate to each other. So here you can see various tables in a database along with their attributes. So these are the columns in this table. So for an author, you have their name, address, and a web URL. You can also see the relationships. So it looks like a book can have authors, and so the author information is in here, and that's borrowed from the author table. And this is where you can see the power of a database, because author might be referenced many, many times in various different books in the book table, but you only have to change the author's information in this table. And every time you pull up the information in the future, that change would be cascaded because you're pulling fresh from the author table, the data that relates to the book table. So this is how we model out the relationships in a diagram. Entities are represented by rectangular shapes. So these are all the tables represented by rectangles. And then the lines between the entities represent relationships between them. Next up is a little overview of the SQL language. So the SQL language actually comprises of various subsets, including DDL, which is data definition language. So this is language used to create or alter tables or users. So you can create tables, you can alter them, which means you can change the column names in there or types, or you can drop or delete a table, you can rename a table or a user. So data definition language is used to change the users or the tables themselves. In contrast, I'm going to skip this one for 1 second just to go over the comparison. The data manipulation language is used to change the actual data inside of a table. And so insert, update, delete, those are changing actual records in a table or adding. So that's the difference there. This changes the organizational layer, whereas this is used for changing the actual contents of the table. We also have the query language. The data query language is used just for select statements, which is used to retrieve data from the database. The last two, we haven't gone over these in a ton of detail in class, but they're advanced database concepts. So granting or revoking has to do with rights that users or applications or application users might have in a database system. So, you may have a primary user of the database, and that might have a ton of privileges. They can access records, they can change them, they can delete them. However, you may want to create some dummy reporting roles, which, only have read access and certain things like that. So data control language is used to control those privileges that various users may have to various different parts of the database. Lastly, we have transaction control language. This is also an advanced concept. So say you have an insert statement and you need to insert data into various different tables, but you need to make sure that each successive operation goes through before you do the next one. And so that's where you would use transactions is, only create an order if you were able to create the customer record first, because without the customer record, the order record is kind of useless. And so you would wrap all those operations into a transaction. SQL operations, and so this is where we're actually pulling data, inserting data, CRUDing data in the database, and so create, remove, update, delete. So let's start with the similar table to what we were working with before. So assume the car table contains, it's not 3 anymore, so it contains records of cars with these models and manufacturers. So we have a manufacturer column, a model column, and an ID column. And how would these records be ordered? In the following query. So select manufacturer and model from car order by model and manufacturer. Okay, so the first thing we need to do here is the system's going to order this table by model first in alphabetical order. So the lowest model is A, Aventador, so you'll get Aventador first. There's Aventador. And then next up should be C, Civic, so you'll see Civic. Okay, so it's alphabetizing the model field first. And then we put comma manufacturer here. That means that if the model is the same, in that case, you want the manufacturer alphabetical. So since Suburban is the same, it would then alphabetize the manufacturer. Now it's displaying it flipped because we said, show me the manufacturer first and then the model. So we're ordering by model first, manufacturer second, but we're displaying the manufacturer first, model second. So a little tricky there. You kind of have to sit there and think about it the way a computer would parse this operation. Next up is a where tag. So if you want only a subset of all the records there based on a condition, you would use a where clause. So select model from car where manufacturer equals Ford will give you focus. So manufacturer was Ford, and that's the only record with the manufacturer being Ford. Next up, we have wildcards, and so sometimes you have a lot of data and you're trying to match it to, you don't know exactly what the answer would look like, or you're trying to get a bunch of different data that satisfies a bunch of different conditions. You can use like in conjunction with one of these wildcards. And so if you have in the where, if you add a percentage sign, that will represent 0, 1, or many characters. And so instead of OR, if you just put this will match to Ford or FD or anything between F and D. So that's how you'd use a wildcard. Then you have the underscore, which represents a single character. And so if you did this, you can only get a manufacturer with 3 characters. However, if you did this, now you can say, okay, I forgot what the third letter was or character is, but I know there are 4 characters total. Now it'll replace the R and actually get us Ford. So they can be used in combinations as well. And so another way of saying Ford would be this. And so you're saying, the word can have any number of characters before the R, but only 1 after. And so this would also satisfy Ford. Then we also have comparison operators. And so this is for kind of arithmetic functions or comparisons. So you can compare equal to. Notice that in some of the software development programming language type comparisons we did, we have 2 equal signs in some languages, but in SQL we only use 1 for equality. And so equal is equal to, greater than sign is greater than, less than is less than, greater than equal to, less than equal to, and then we have not equal to. And so here's an example, select ID from car where, we want the first 10 that were ever produced. And so here's a query that was satisfied that where ID is greater than or equal to 1 and ID is less than or equal to 10. And so you definitely want ID in both of these. So something like this would not work. Logical operators. So we have a bunch. We have and, which is only true if all conditions are true, or where any of the conditions could be true, and then that'll satisfy the whole condition. We have like, where if it matches a pattern, so that's if you're using these wildcards. We have not, that means, if the following condition is not true, that'll satisfy this. And then we have between, which is only true if the operand is between a range. So, we could have used this, or we could simply say select ID from car where ID between 1 and 10. So with between, you don't have to say ID again. So it's kind of a nice short form. And here's an example of using a logical operator. So select star from car, select all records from car where the model is Ford and the color is silver. And so that'll give me all the silver Fords. Here are special other commands we can use to interrogate the system. And so describe car would give me all the table, column, and settings that apply to that table. And so I want to know about car, what attributes are there, what settings are applied to that table. I could just say describe car with a semicolon to terminate that command. Then we also have show. So if I want to see all the database, all the tables in a database, I could just type in show tables and it'll show me all the tables in that database. Next up, we have a little web development section. So this is what a URL looks like. So it starts with www, ends with a .com, .edu, .net, and then it can have some path after. And so this is what you type in your browser to go to a website, certain part of a website. There are two protocols that the web uses, HTTP and HTTPS. HTTPS is encrypted using transport layer security. And so HTTP is a less safe option if you're passing any sensitive data, or just most of your browsing should be on HTTPS secured websites. This is an IP address, so it's tied to a server or machine. And so if you had tried instead of localhost to put your local IP address, you could have gone to your XAMPP, PHP, myadmin, and all that. So this is a way to access a server or your local machine. Next, we have a file path, and so this would be a path of something on a server or a computer. And so if you are a Windows user, or if you have a Windows server, this is what a file path looks like, and it's the directions of how to get to a file on a computer. So in a URL, this path right here is considered the server name. And so go.wigtech.edu, everything that comes before the specific path is the server name. And so go.wigtech.edu, mail.google.com, they're all the server names, and they identify the general location of the target document on the web. And after that, you can just follow the path to tell exactly where the file that you're trying to access is. We have two types of linking or pathing, relative and absolute. And so given the path, say example.com/courses, and you're on the courses page, the absolute path, I think that's the easiest to understand, is the overall path of a page or a file. So CTI 110's absolute path is on this server inside the courses folder, you have CTI 110. However, relative to the server name or relative to courses, so if you're already in courses, the relative path is CTI 110. So if you're already in courses, you could see CTI 110 is right there. However, if you don't have any context of where you are, you would use the absolute path or the absolute link. Lastly, there's a small blurb on testing. And so web developers, you all have been building so far on your local machines, your own personal computers. And then when you push your code out to production, say you're working for a large company, you would have the production server where your customers are going to perform transactions. But then you also need another place to push changes to without disrupting your customers in case there's an outage or you push some bad code or something went wrong with the release. And so web developers often maintain a testing server that is a lot like the production server, minus, that it's not publicly accessible usually, and it may require a password for access and things like that. But it's basically just a playground where web developers can test new features and functionality. So that's all I have for today, and best of luck with the exam. Thank you.